Hello, everyone. This is Brittany Hanley, and this is my project for OCG 540 on the iridium layer. Okay, a couple of definitions. Iridium is an element that's found in extremely low abundance on Earth, much more often found in extraterrestrial matter like comets and asteroids. The KT or the KPG boundary is the iridium layer. It marks the end of the Cretaceous period and the start of the Tertiary/Paleogene period. Chicxulub is the crater where the asteroid is believed to have made impact with the Earth. It's located on the Yucatan Peninsula and is partially underwater, as it was when the asteroid hit about 65 million years ago. PGEs are platinum group elements. Iridium isn't the only element found in the KPG boundary, and all of the elements in this group are only present in large amounts in extraterrestrial matter. So, what is the iridium layer? It's exactly what it sounds like. It's a layer of iridium and other PGEs in the Earth's crust that dates back to around 65 million years ago. This is a picture of the iridium layer, and it's very clearly visually distinct from the sediments that's above and below it. Iridium is extremely rare on Earth, but is common in space materials like asteroids. This iridium layer in the crust has about 1,000 times more iridium than the surrounding layers, which leads geologists to believe that there was some kind of asteroid impact at this time period. The iridium layer was first discovered in Italy and Spain, but it's also found in different places all over the world. So that means that whatever event deposited this iridium must have been extremely large. On the Yucatan Peninsula, scientists discovered what was first thought to be a buried volcanic crater. But once they took core samples of the rock, they didn't find any volcanic material within that core sample. Instead, what they found was high levels of iridium and PGEs, which indicate that this crater was formed by a massive asteroid impact. Researchers dubbed this crater Chicxulub, which is a Mayan word that roughly translates to Tail of the Devil, which is a pretty cool name for a crater. So the impact zone, which was anywhere from around 900 to 1,800 kilometers surrounding where the asteroid hit, was totally dissipated. The asteroid hit Earth with an estimated force of around 100 million megatons and produced a huge shockwave and lethal winds, which were estimated to have been at speeds over 1,000 kilometers per hour. Since the impact site is partially underwater, huge tsunamis devastated coastal ecosystems in the Gulf. And we know this because there were core samples taken in Texas and Mexico that show tsunami backwash deposits around this iridium layer. So obviously there were a lot of global effects from this huge asteroid impact. Debris and chemicals found in and around the iridium layer can tell geologists how the impact affected Earth's environment. Some of the things that we know occurred after the impact that were extrapolated from the sediments are acid rain, global widespread wildfires, dust and aerosols in the atmosphere, ozone destruction, and greenhouse gases. The impact ejected so much material into the atmosphere that sunlight was essentially unable to reach the Earth, which pretty much stopped photosynthesis in the ocean and on land. We know this because in the sediment cores, we can look at the fossil records below and above the iridium layer. From this, we can see that there is a massive die-off right at this iridium layer. This asteroid impact is what's presumed to have caused the extinction of the dinosaurs.